Okay, thank you. Welcome to ACDE number 213. I posted a link to the agenda in the chat here. Couple things to discuss today. So on the Fusaka front, there are a few things that came out of the testing call that we should touch on. So around the gas limit, and then some mod XP questions. Then for the finalization of the scope, we discussed making some changes to RIP 7212 last call, which are in progress, and then wanted to finalize the set of EIPs for DevNet 2. So do those. And then continuing from last week, we started discussing potential headliners for Amsterdam. So there were a few EL related ones that had been proposed that we should cover. There are also other EIPs that have started to be proposed. I think we probably shouldn't take time on the call to discuss them unless anyone feels very strongly about it, but it's probably best to stay focused on the actual fork headliners for now. And then just as a heads up as well, the next week, because of the in-person meetings, we'll cancel the calls, and I will be out in 2 weeks, and OnStar will be taking over for ACDE. But yes, to kick things off, so on ACDT Monday, there was a discussion about raising the gas limit and kind of testing it on 60 million on Hoodie, and then moving to mainnet. And after that, I know there's some follow-up conversations about like what the right approach should be to actually increase it, and are there things we want to see or like potential blockers there. So if someone might want to recap kind of the outcome of that discussion and what the open questions were about like actually moving forward with this on mainnet.
Yeah, I can give a brief update. So on Monday on ACDT, we asked client teams if they saw any other blockers before we started to signal raising the gas limit on mainnet for 60 million. However, I mean, in the last couple of days, I think once we started planning for Berlin Interop, we realized that we're going to be doing a lot of work on gas limit performance testing anyway. So in my opinion, we probably should wait to make a decision until that track is done. And by the end of next week, we'll have a better idea about what our scaling limits are, what we would have a few more eyes on the gas limit from a security perspective and so on. And then probably the ACDT the week after, we can make a call on how we want to increase the gas limit.
And there's a question in the chat, yeah, about the intention around either jumping to 60 million straights or having some intermediate steps. So I don't know if, yeah, is that basically what we're hoping to figure out in the next week or so?
Yeah, I think that would be one of the discussion points. I don't really see any problem with doing intermediate steps other than coordination overhead. I think it takes us quite a bit of time to go through the gas limit increase process. So yeah, I think we should try to prevent as many steps as possible, but at the same time, not have the steps too granular.
Thanks. Anyone else have thoughts, comments on this? Yeah, Micah?
So the testing team appears to have done a great job at digging very deeply into whether or not stakers will run into problems with the high gas limit, which I think, again, I want to acknowledge that excellent work. But I still haven't seen any research or discussion into how the gas limit affects other participants in the Ethereum network. It seems everybody's focused on stakers and builders, and no one has even talked about RPC providers, or even more importantly, in my opinion, people who are running their own local RPC clients. And how this affects them. I think the storage issue affects those people far more than affects people who are paid providers. These are end users who, hopefully are running Ethereum on their home computers. I've talked to a handful of people, just Ethereum developers across the ecosystem over the last few weeks, and there seems to be a lot of divergence in whether or not we care whether people can run Ethereum at home. There's some people, Dankrad is very forward with this, and I very much appreciate how candid he is, where he just says, he doesn't think that Ethereum needs to be a tool that people can run on their computers at home, and that's acceptable. There are other people in the developer community who seem to think that they should be able to run clients on home computers. And so it seems like there is a mismatch between who we're targeting. Do we care? The question I would like to see answered very clearly is, do the Ethereum core devs as a group want people to be able to run Ethereum at home on their just home computers, or is that something that we're no longer targeting? It used to be a target back in the day, and there's, again, some subset that don't think it's a target anymore, and these gas limit changes will affect that. And so I would just like to see more discussion and research into how this affects people besides stakers and block builders.
So I guess, yes, there's a difference between stakers, block builders, and just node operators who want to validate the chain running at home versus running a full-on RPC service, which is by definition more resource intensive. We had, I don't know, Oscar posted in the chat, we have this EIP that attempted to define some of these constraints, EIP 7870. And I think throughout this discussion, it did not come up that we should optimize for home RPC providers. And so I feel like this is probably the right, I don't know, distillation in a way of the opinion. We should serve people running their local node. Obviously, you need to be able to make local RPC calls to that node. But I think when you start to go into running a kind of high usage endpoint that's potentially used by others, that feels that feels like a qualitatively different thing.
Yes, it definitely does. There's 3 or 4 different demographics, right? You've got the block builders, you've got, which were, based on the research roadmap, it sounds like block builders were expecting to be super high-end data center type hardware, doing ZK proofs, yada, yada, yada. You have validators who we still want to support, home, quote unquote, home stakers. These are people who, can put a lot of money into building machines and whatnot, and they have hardware, but maybe not a data center. And then you have RPC providers, again, probably data centers. And the last group is the group, again, this used to be a group of people who existed and dominated the Ethereum ecosystem and have basically disappeared, as Dankrad mentioned in chat here, which is people who just run Ethereum on their home computers. They do not buy extra hardware. They do not go to the store. They do not spend a lot of time thinking about Ethereum. They just double click an installer, run it, and it runs in the background. Besu has a thing in their client where you can run a flat database. This is a somewhat trusted system, though it could be made trustless with some additional R&D. And this runs in, I think they said 80 gigabytes ish right now for the full state. And so in under 100 gigabytes, you can run an Ethereum node today. And with additional R&D work from Ethereum core devs, we could make that possible in a trustless way. As we increase the gas limit, that increases the rate at which that 80 gigabytes grows. Now we're not talking about 80 gigabytes plus 3 gigabytes a month. We're talking about 80 gigabytes plus 6 gigabytes a month. And that adds up real quick. And so, yes, 3 gigabytes a month of state growth, when you're looking at 1 or 2 terabytes, is not much. When you're looking at 80 gigabytes, it's a very significant increase. And so that's the group that I really feel like, if we're going to just cut them out, we need to make that clear that we're doing that.
I do think, yes, I do think this is kind of clear in 7870. Basically, this is effectively just a non-staking node, and or a full node, basically. And I think it's been pretty clear in the past few years that the median way to run this requires extra hardware. It should be consumer grade hardware, and it should be basically not not out of reach for people to do this. But I don't think, I think we've passed the point of saying we can optimize this for effectively a couple hundred gigs of storage and nothing else. Some client implementations might be able to help with this, but yeah, like it's definitely not like the median, yeah, the median approach. I guess, yeah, okay, Oscar, and then yeah, let's do that.
Yeah, I just want to say that, like, I think one way in which maybe I think many people at least have expressed in the past the intention to change a little bit how we do things in Ethereum is maybe that we want to still like continue to take these concerns very seriously, because obviously this is crucial to the core of Ethereum that we actually get this right, kind of this trade-off, and really understand the costs of scaling and when that is acceptable and when it isn't. But that we stop doing it the way where we always basically first get blocked on like 7 rounds of conversations before we have exact agreement and only then make any moves, because then in the meantime, the experience for actual users is just really, really bad. So I personally would just say that basically the process here of saying over the next 2 weeks, with the in-person events and everything, we basically make initial decisions for the short term. And we're only talking about at most a 1 point something X increase, right? Like 60 million is not even double today's level. And then going forward, we will have a process, and I think Micah, I'm happy to reach out and have you be involved in this, where we will also over time become more precise in distinguishing between different types of nodes, including RPC nodes explicitly, so that we actually have a fundamental basis, and then we can still have the conversation on Orcodefs to which assumptions to use there versus not use there. But I think basically for now, we should still move forward with this process and not be blocked for 6 months while we have that discussion.
It's Damkar.
Yeah, I mean, I think like when I hear these discussions, I often just feel like it's really disconnected from reality. Like, I mean, I think like we're still thinking about Ethereum as if it were 2015, and like people want to run like a home, like this node at home that has all these properties. But like the median Ethereum user now is so far away from that, that's pretending that we still get the same, like we're still operating in the same space and still get the same benefits, is like not very reasonable to me. Like I think like in practice, we know exactly, like most of us know exactly what normal Ethereum users do, and yet we keep designing for something completely different. And I think like we need to move away from that and like be like, well, this is what is really happening, and like we want to get the median Ethereum users the best properties that we can, rather than like a small set of like people who like do something very different from that.
Lucas.
I'm somewhere in the middle. So I agree with that we should be able to run Ethereum nodes on standard consumer hardware, and we can. And if you need to buy a SSD, if you want the full history from Genesis, it's also fine. And if you need some decent connection to keep up with the network, and it's also fine. If as long as it's reasonable and available in a lot of locations, it's so yeah. I don't see a problem. You can build blocks with Nethermind, and not only Nethermind. Probably a few hundred megagas blocks. You can process them. You can store them relatively easily. With newer architectures like Aragon 3, even Archive node is somewhat reasonable, but it's also fine for us to say if you want that by a SSD, right? It's technical limitation. We would love not to have that, but it's fine. I do agree that we should maybe focus a bit more on EIP for force and having it post merge pruning of that to help with that, but that's about it.
Thanks. So I guess like yeah, the main thing I wanted to revisit today was like, yeah, whether we were okay just whether we were okay just moving forward with 60 million on mainnet as of now, it does seem like there's more data that we want to collect, at least in the next couple of weeks. We should figure out the what like the requirements are, whether we want to do a one-off like bump to 60 million or to be more gradual. And I expect in like 2 weeks or so we'll have a bit better of an answer there. Yeah, Marcin?
Yeah, I would like just to add that on recommended specification from 7870, if we are running tests on it, and there are like the worst scenario is performing at about 20 megagas per second. So we need to be conscious that there will be a possibility to craft a block which will take 3 seconds about 3 seconds to process on 60 megagas or 60 mega gas limit. I'm not saying that it's a blocker, but we just need to be conscious about that.
Yeah. Okay, so I do want to move on for now because yeah, we could probably spend the next 90 minutes talking about this. But yes, let's follow up on this in the next 2 weeks. And then there is a Discord channel, gas limit testing. So we should use that to actually talk about like, yeah, what the constraints are and how we're addressing them over the next weeks. I guess, okay, so following up, there were 2 minor updates to at least some of the Fusaka EIPs. First off, Powell had an update to 7883 that he wanted to discuss. Yeah, I don't know if you're on the call, Powell.
Yeah, so I can give you some insights about that because I was in touch with Paweł about that. This EIP is proposing, this PR is proposing 2 changes. We already agreed with Paweł that one of them will be withdrawn. So it is proposing to not increase the mean price from 200 to 500, but it's opening the doors for some edge case scenarios which we don't want to have. So it will be reverted. So we'll keep increasing it from 200 to 500. And like right now in 7883, there are 3 small changes in the code, and this will add the 4th one. So for on a real network, base and modulo are always have 32 bytes or more. But in theoretical scenarios, which we can like craft to be worst case attack scenarios, etc., we can craft modex usages with smaller amount of bytes for base and modulo, and this PR is increasing gas price. Like we are counting price if it is 52 bytes, even if it's smaller. Thanks to that, like we will cover some edge case scenarios, and they will have 0 impact on common cases on mainnet. So it's a clear win, and yes, I would like to add this 4th change to this EIP.
Thanks. Has anyone else had the time to review this or have comments on it? Okay, otherwise, yeah, let's have people review this async and try to make a decision in the next week or so. Next up, So on the last call, we discussed that some issues with RIP 7212 needed to be addressed, and that led to kind of a change in the spec. So we opted to effectively write a new EIP that provides basically the same functionality, but addresses these issues. Carl has been working on that. I know, Carl, are you on the call?
Yeah, hi. Yeah, so I mean, a few things. Basically, why do we want this? It's like the most ubiquitous signature scheme across the web and most modern tooling stacks. Like it's basically the SHA-256 of the signature world. Like defaults in TLS, OAuth, SSH, for VPNs. It's like massive. But the main gain that we care about here is that like it is the signatures that's used like embedded in most hardware. So like Android key stores, Apple Secure Enclave, YubiKeys. Anywhere where you can use a passkey, you would now be able to just sign. So that means we could like switch to a model where you just sign transactions with Face ID or fingerprints or whatever works for you. So I think really massive UX unlocks. This exists in the form of RIP 7212, deployed across many of the L2s at the moment. As I mentioned previously on here before, we had a small bug in 7212, which like basically had undefined behavior in a degenerate edge case. And so we kind of needed a new spec for that. This EIP 7951 is identical from an interface standpoint. So from within the EVM, you definitely won't be able to tell the difference, but we just patched this one edge case and have extensive tests for it. So that's I think something we should really consider having in this fork. We had BLS in the previous fork, and I think everyone's a little jaded after that. I totally understand that. This is a much simpler cryptographic EIP. So it only has one interface / entry point versus BLS, which had 9, I believe. And there's only like internally cryptographically, there's only like one group where the whole BLS thing has 3 and they all interrelate in weird and wonderful ways. Because it is so ubiquitous, there are just many libraries that have it. And this EIP matches the interface of all those libraries. So we don't use EC recover like we do for the K1 curve. We use just verify as the interface. Again, just because that matches all the existing libraries. So it should just be plug and play. And unlike the BLS things, we already have extensive tests before we wanted to do this. I think there are 780 odd tests in this new version of the EIP. So I think it's in a really solid place and ready to ship, and something that from a UX standpoint would be fantastic if we can just have in there. As far as I'm concerned, the major unknown is just gas cost benchmarking. There's a number in there now which matches the RIP 7212. My intuition is this probably a little on the cheaper side, but yeah, I think we should we should basically just need to implement this in clients and see where that would see how much that costs relative to other things, and then we can get that. Right.
Yeah, thanks for sharing. And so I guess yeah, there's two like decisions here. The first is just like, are we okay swapping out RIP 7212 for this? It seems like, yeah, we obviously should. And then I think next item is just what do we want to include in DevNet 2? So I feel like we should make the decision about the DevNet as a whole rather than just 7212 or not. But yeah, before we do that, just like, does anyone have any concerns swapping 7212 with 7951? Otherwise, we can just do this after the call. And then, okay, so assuming there's no concerns, basically on the last call, we had SFI'd a bunch of EIPs for the DevNet 1 spec. DevNet 1 is not live yet, but we did want to finalize the potential list for DevNet 2 today, meaning that like, assuming that that 1 goes well, this is what we would add in DevNet 2 and then finalize the scope for Fusaka. Finalize the scope for Fusaka. So the 4 EIPs we still had in the CFI list were the pay opcode 7212, which is now being replaced by 7951, 7907, and 7934. I guess, yes, I would like to hear from client teams, like which of these should we prioritize for DevNet 2? And then I think what doesn't get included for DevNet 2, we would probably just decline for inclusion now and leave the rest in CFI once we've, so once we've shipped DevNet 1, we can move the rest to DevNet 2. And so Gabriel, to your question, like so far, nothing has been confirmed for DevNet 2. And we want to figure out of the set of EIPs we already have set for DevNet 1, what do we want to add in addition to this? And I'll post the full list of EIPs for DevNet 1 in the chat now. So this is what we had in DevNet 1. Yeah, Ben?
So the 7212 replacement, block execution size, I'm living on pay. I'm fine with that. The meter contract size still needs work. So would be against that, but potentially we could just do in the interim like 50% on the contract sizes.
Okay, so sorry, so that was 7212, and then what was the other one? Sorry, you said, I just want to make sure I got it right.
7934.
Okay, okay, yeah.
But
yeah,
7907 still needs a bit of work, and would be willing to swap that for Fusaka for like a 50% bump in size, and then look at doing the full EIP for Amsterdam.
Got it, thanks. Andrew?
So I agree with Ben. It's should be the R1 precompile and the RLP execution block size limit. I personally don't have a strong view on the increased limit EIP. As to the pay opcode, I think it has some implications to the tooling, and it's not trivial. So if we decide to do it, I would rather do it early in Amsterdam, so we have more time to think about it and test it. So I wouldn't do it this late in Fusaka.
Okay. Anyone from Besu or Geth?
I put my personal opinion on the chat already. I like 7212 and 7934. I don't mind the others, but I also don't really need to push for them at this moment.
Okay. And then, yeah, Gabriel, you're being put on the spot for Besu.
If he's not near a mic, I think we don't really have a strong opinion. We published our earlier things. I think the pay op code is good. We'd like to see that included.
Oh, okay. Marius?
Yeah, this is actually Felix. I just thought maybe I should give, because Marius said he has his personal opinion. So I do think that, like, from my point of view, the 7212 is pretty important to ship. Like, this has been sitting for so long, and it's kind of a small one, so we should just have this. And the 7934 for me also pretty important one, just to basically be able to constrain it. The other ones I have less an opinion about, but I know that the 7907 is pretty important for the community as well. So I would say like if we can pull it off, then it's probably also something good.
Thanks. Yeah, Roman?
Yeah, but this is a response to Felix. I would recommend to catch up on 7907 thread, which I was unable to do yet. There was basically a long discussion on the implications. And I posted the comment earlier in the chat as well that we're for 7212 and 7934. And we're generally supportive of 7907. But given the extensive discussion, I cannot give opinion right now because I have not caught up yet.
To be effective, 7907 really needs a change in the database structures of the EL clients, and it's a bit close to Fusaka in terms of where we are in the DevNets and things. If it was like at the start, I would say it's fine, but it seems a bit too much at this stage.
Okay, so I guess if 7907 is going to be too complicated, then this is the last DevNet that we want. It seems like 7212, 7934 are pretty much supported by everyone. So I would keep those. Hey, and then yes, should we decline effectively 7907? And I would also lean towards declining 5920 because it seems like it has pretty mixed support, and also had some unintuitive implications.
What do people think about trying to do 7907 for this DevNet? And if we find the database changes are just going to be too complex, we drop it. I know the database changes for us is only 100 or 200 lines of code. It's not substantial. I don't know if that's pretty different for everyone else.
Yeah,
but it's one of those things.
Changing all the opcode, pricing. I mean, I think it would be better just to increase the contract sizes by 50% for Fusaka as an interim feel good, and then not feel good, but it would be useful for devs. And then in Amsterdam we do the fuller, more complete thing.
Yeah, but Amsterdam already has a lot of things that people really want to do that are pretty super critical, and it feels like we can just focus some effort now over the next month and really lock in 7907 now when there's not so much going on in the EL. And then Amsterdam is open for all the different EIPs being proposed.
Yeah,
I just see us having the same conversation again in 6 or 9 months, and then saying, there's just a lot of stuff going into this fork. We should just wait till the next fork.
Yeah, but it's the fact we're at the end of the fork almost. That's the main point.
I don't think we're at the end of the fork almost.
Okay,
Robin?
Yeah, quick comment. My understanding that the problem with 7907 was not this additional index, but other explored implications of storing these huge contracts in the database. Nobody just did the analysis.
I mean, I think Julio did look into it, and sequential reads is extremely fast from disks, so it's not really a major issue. But it's one of those things where we probably aren't going to get the best information until clients actually start to look at it. And I don't think that it's not a big lift to begin looking at it. The whole implementation of this is probably sub 500 lines of code. And I think it's a good stretch goal for us for the next DevNet. And if we start implementing it and we learn that this is not going to work out, then we drop it, no worries. And we look at Amsterdam.
Okay, I'm gonna flip. I'm persuaded. Ref is also for including 7907, or at least trying to implement it. And if it's too difficult, we can always take it back.
I guess
Like, I
one
think
thing that,
ultimately the thing is that this is a very important EIP for the community. They've been asking for this type of thing for many years, and we're close. Like, we're really close. We just need to push through a little bit over the next month, and I think we can give it to them.
I think one thing to note about DevNet 2 is even though DevNet 1 already has a bunch of things in it, the two other EIPs we're considering are quite small. So 7212 is not trivial, but I believe most clients already have it implemented and would only need would only need like to do the changes from EIP 7951. 7934 is like also pretty straightforward. It's like a check on the size. So I guess like, yeah, do we want to commit to have it in DevNet 2? If it doesn't work out in DevNet 2, we do that. And I get there's two comments about like tentatively including. This is why we call it scheduled for inclusion now and not included. Like, if we learn something as we're working on it that makes it no longer be a good fit, we should reevaluate that. But if we feel like we have to actually include it on the DevNet, then I think it makes sense to ship DevNet 1 and then potentially have that be like the one slightly more complex feature of DevNet 2. And if it works out, then great, we ship it. If we find that the issues are too big and that it's going to delay the fork, yeah, we should just remove it. So I guess Geth and Reth are in favor. I know Besu, Nethermind, Aragon. Yeah. Do you have thoughts about this? If we did this, I think we should probably not do pay opcode in DevNet 2. So this means I think if we include 7907 and there's some concerns, we should probably decline pay from this fork. Yeah.
Happy to experiment. See how it goes.
You're what, sorry?
Happy to experiment, see how it goes.
Okay. Okay. Besu, Aragon. Yeah, Andrew.
We can try experimenting, implementing it. So I haven't thought about it in detail, but well, at least we can start experimenting with it.
Okay, so let's do that then. Let's do so this means we'll leave 7212, 7934, 7907 in CFI for now, move 5920 to DFI, and then once we have shipped DevNet 1, assuming things don't break there and there's not like a bigger correction, we would default to move these three IPs to SFI and be part of DevNet 2. And then if we find some issue with any of the EIPs, we should reconsider whether we want them in the fork or just to remove them. And if there's some investigation that we can do on 7907 in the meantime, yeah, we should do that. Yeah, but I think we're set on the maximum possible scope for Fusaka. So as of this point, anything that's not in this list is effectively out of scope. And if everything goes well, then what's in SFI now and the DevNet 2 scope will be what ships.
So that includes pay opcode is what I'm hearing?
No, I would say if we move forward with 7907, I would move to not do pay in DevNet 2 because it seems like most teams didn't support it. Then if 7907 is already going to be complex, I try to limit complexity, but yeah.
Okay.
Okay.
If you put in the glass.
Yeah, obrigado.
Okay, great. So yeah, that's it for Fusaka. So looking ahead for Amsterdam, like we discussed previous couple calls, we want to start and consider headliners for the fork. First line on that before we discuss other EIPs. So there were 3 headliners proposed already. I wanted to make the space if either of those proposals on the call to yeah, give a quick overview, and then I think it would be helpful if people on this call have like questions or concerns that need to be investigated to raise them, so that the champions for these headliners can go and look into that over the coming weeks. There were also a bunch of like smaller, more minor EIPs. I don't think we should start making decisions about those, but I wanted to at least flag them so people can start proactively reviewing them. But yes, the first headliner candidate was Fossil. I don't know if anyone championing Fossil is on the call. Okay, I linked the 3 threads in the chat, so we can follow up async and discuss on another call. Second was EVM 64.
Yeah, I'm here. So I'm the champion for EVM 64. So this is something that I hope I'll probably give a formal like introduction of this later. But at this moment, I really want some more reviews. But the basic idea is quite simple. It's just we define a new group of opcodes that are only operating on the least significant 64 bits of a stack value. And the good thing about this is that we can then, I mean, each operation is then significantly faster because you only have to do one statement instead of 4 for the 256 bits. We currently have 2 different versions. The first version is built directly on the legacy, or I would probably just use this name, legacy EVM, which we define a prefix opcode and the other set of the opcode that follows it is a 64 bits operation. And the good thing, the advantage of doing this is it's less complicated, and we just have I mean, we have we can make the interop with 256 bits really easily because it's just a different set of opcodes. It can work with other opcodes really easily. And the second option is built on top of EOF. In this case, what EVM64 will need is a change to EVM format, which does, yes, we have a question already. No, so yeah.
Sorry, yeah. After this, I just wanted to circle back to Fossil for a second. I was just raising my hand for that.
Okay, yeah, I will. Okay, I'll continue. Then the second option is built on top of EOF, and in this case, we do need to do a change to the EVM format, which adds a type parameter into the code section, so the interpreter can know whether it's running a code section of the legacy EVM or EVM64. And I think this is the option I would prefer. It will be open up a lot of optimization approaches for us, and we can basically write really fast EITs for UM64, like building on top of existing UI formats quite well. And yeah, this is basically the current proposal, and I would really looking for some reviews at this moment. If you have questions, I would really like to answer them. So, yeah.
Okay, thanks. Any questions? Oh, there's a question by Kev. There's a question by Kev around whether this has been prototyped and whether we have a feeling of what the actual performance improvements are.
I have a prototype in Rust EVM is for the option one, which just directly built on top of the legacy EVM. I haven't really benchmarked it yet, but I will hopefully do that soon. So, but I mean, if we write a GIT for that, it will be faster because we are just now doing the actual work of the actual 192 bits. So for those computationally intensive operations functions that we can only use 64 bits, so this will be beneficial.
Thanks. I think having hard benchmarks would definitely be helpful here. Are there other questions, comments, concerns? Okay, then otherwise, I think, we can continue this conversation on these positions, and then, move on to fossil. So I think, Thomas, I think, is on the call. Maybe if you want to start to give like a quick overview, but then there were already a few questions about fossil in the chat, so we can get to those as well.
Yeah, sure. So maybe first I can signal that I did give like a more sort of like fleshed out presentation on ACDC last week. So like everyone can sort of like also like refer to that presentation, I guess, if they want more details. But yeah, fossil is EIP 7805. We presented it as a potential headliner for Amsterdam. What it essentially does is basically really improving Ethereum censorship resistance by enabling multiple validators to just make sure that any transaction that is valid according to the protocol rules is actually included in Ethereum blocks. And basically it does so by having like the multiple validators build inclusion lists that are filled with transactions from the public mempool to impose some constraints on the builder. It has like a bunch of interesting properties. I think maybe highlighting why it matters, it's because I mean, today we have like more than 80% of all blocks that are produced by just like the two builders, and they can just like decide whether to include or exclude transactions sort of arbitrarily. So folks, basically what Fossil does is like it fixes this by empowering like the more like obviously decentralized set of validators to enforce inclusion constraints on builders blocks. For who it benefits basically everyone, because it ensures like all the transactions are included on chain without sort of like any discrimination between different kinds of transactions that are just like arbitrarily decided by an external party instead of the protocol. Yeah, it has some benefits like you could like tie to scaling and improving UX, but of course like the main very big feature is improving censorship resistance. And why now? I think, yeah, it's really a solution to basically mitigate the censorship risk we've been having since PBS was introduced. And I don't know, like the builder market is very, very centralized. It's like sort of inherent because it's due to private order flow, and I don't think it will change. And yeah, we have observed like sort of like increasing vertical integration across builders, relays, and searchers over time, and like not the other way around. So yeah, I think there is a question also of like the urgency of including it. So that's been discussed and proposed a lot. Like there was another EIP. I think fossil is much better in many sense, but like yeah, there's a case for fossil, I think, because now we are like quite lucky that there's not much censorship on the network. I feel like in the future that can definitely change and make the inclusion of something like fossil or proposals to improve, I don't know, censorship resistance and privacy much harder to get in the first place. So yeah, I think there is some big urgency in taking care of this. In terms of technical readiness, it's also like now fully implemented in 5 different clients and running on local DevNets with Prism, Lodestar, Teku, and Geth that are interoperating with each other. Soon Lighthouse, I think. We've had 11 fossil workouts, and we made sure like it's compatible with everything that's sort of like already in protocol and also like other proposals. So yeah, I think there is a good case for fossil. I really want to for us to move this forward and not wait until things get bad to get a proposal like fossil included.
Thanks. One question that came up earlier in the chat was just the interaction of fossil with delayed execution and block access lists. I don't know if you have like some thoughts on that, Thomas. And
yeah, so there has been some recent progress on that front. It was mainly driven by Tony and Francisco, but there are like some very nice integrations between the 3 of them. So it basically works with delayed execution, but like there are like some tricks that you have to sort of like deal with to make it work together. And block level access list actually sort of like make that easier. So there is a write-up by Tony that I can link, but there is a nice integration between the 3, which is very nice.
Thanks. Any other questions, thoughts about fossil? Okay, then yeah, thanks a lot for jumping on for the quick overview. Next up, the other proposed headliner was available attestations. It's the one I have the least context on. I'm not sure if the author is on the call.
Yeah, I'm here.
Hi.
So,
yeah, do you want to give a quick overview?
Yeah. I will give us quick presentation for this. Sorry, wait. Wait a few minutes. Okay.
Yeah, thanks.
Okay. So, yeah. Hello, everyone. So today I'm excited to present my EIP 7942 available attestation. So this is a proposal designed to make Ethereum proof of stake fully reorg resilience. So first we talking about what is reorg. So as we can see in the table, so despite many advances in Ethereum proof of stake protocol, the system also faced many new attacks. So Some of attack we have already know about, like the accent reorg, the balancing attack, it's a Leibniz attack, and other attacks about attacking the Casper, like the bouncing attack. So, and some of the attack like the justification withholding reorg. So these attacks, they mainly focus on um, um, attacking Ghost or attacking Casper, and they mainly cause reorganizations, kind of like so the balancing attack is more powerful and it causes the finalization stop. Also the bouncing attack. So these attacks, they have some mitigation by Ethereum. However, some of this mitigation has its limitations. Like the proposal boosting, the proposed boosting was first.
Mitigation.
Oh, sorry, I can't hear. Okay, so the proposal boosting was first proposed, and it set a very high boosting, and it caused sandwich reorg, and then it is degraded to 40%, and it cannot fully prevent. However, if we set the adversary stack to more than 20. Also, the bouncing attack was first uh, uh, mitigated by the safe slot, so the justification cannot be updated if an apple has processed 8 slots. However, this mitigation is now removed. So currently, Ethereum is now still facing the bouncing attacks vulnerability. Also, the justification withholding attack is not fully mitigated, and this causes a staircase attack. This is one of kind of the justification withholding attacks variety. And this attack has been fixed in the current Ethereum, and it is not really fully mitigation. And what we want to do is to keep the parent restriction. The idea is that so in the vanilla protocol, so if there is no adversary, the honest validator can propose one block of another. So the idea is like that. So this is block one by one. And oh, sorry. And if there are some proposers that want to do something harm, like they just want to make the system uh, uh, very bad. So what they want to do is that they just build a block and don't point to the previous, they point to another block, and they may cause a chain forked, and there are two chains. And there are any other situation like this is so it may withhold a block and it may release after this block is proposed and cause a fork like this. So this block it will be forked. Um, so this is why restricting the parents is very important. Our idea is that since the honest validators always vote for the head, so if this is a chain and honest validator like the blue one, they always vote for this, and the adversary may vote for this and other blocks we don't know. So what we want to do is make the honest validators vote be the parent candidate. So so the idea is that so if the adversary want to propose a block to this, it cannot be a valid parent since this block it does not receive enough attestations because only 1/3 of the stake is controlled by the adversary, and we assume that we require that more than 1/3 of attestation vote for a block. This block can be the a valid parent. So
Mingfei,
Yeah.
Yeah. I guess like yeah, two things. One is would it be possible to share these slides in the chat to get for people to be able to review async, but also yeah, given the topic, I think apologies about this. We should probably yeah, we should probably discuss this more on the CL call. Yeah, and this is my bad. I think I misinterpreted.
Yeah, I see. So I'm little
yeah. But if you want to post the slides in the chat, I think we can yeah, we can have conversations async as well as on the ETH Magicians thread. If there's anything really important you want to finish like the minute or so, go ahead.
Yeah, I think we will talk about it later. So
yeah, but yeah, I think if people can review the actual slides, that would be helpful.
Okay,
yeah.
okay.
Yeah. Thanks. Okay, and I think those were the headliners that have been proposed for Amsterdam so far. If people want to propose more, there is the ETH Magicians thread for that. Yeah, any other Amsterdam level conversation people want to have. Otherwise, there's also like something about pay that we should get back to in the chat. But yeah, want to wrap up the Amsterdam headliner thread before.
I could quickly talk about block 5 access lists. Maybe we forgot that now.
Yeah, so yeah, I guess one question I would have for BAL is like, do you think that's like a headliner feature and like should be the main thing of the fork, or like I know we've talked about combining it potentially with fossil, potentially with delayed execution, so that might be also worth getting into.
Yeah, I'm not sure about combining it with both of the two, because it's more like block 5 access list is a feature that helps delayed execution and fossil to be more aligned and to work more smoothly together. I saw Justin's comment in the chat that it might not be a headliner. I think we can discuss that. Right now, I would say it has the size of a headliner. I did the specs already, and they definitely looked like it's more of a headliner size, but yeah, debatable. Just to give a brief context on the EIP, it's 7.8.28. Block 5 access list tries to introduce some parallelization. So we can do batch IO plus parallelly executing transactions, or executing transaction and doing the state root calculation in parallel. So this is the primary goal there, and some secondary goals would be that, for example, imagine a CK world, you get the proofs and you want to update your state, and for that you can use the block 5 access list because it essentially contains a full state. So without executing, you could keep your state up to date. And this is also nice for syncing because we could kind of take the healing phase and replace it with the block 5 access list. And then do the check if you're on the right chain at the end by comparing the headers. And regarding helping fossil and delayed execution, so the thing there is that fossil comes with post-execution checks. So you have to execute the whole block, and then you have to check, was there any transaction that was on an inclusion list, but it was not in the block? So you would have to try to append that transaction to the block and see if it could have been appended. If so, then the block would be valid. And block level access lists help there because usually you would need the post state for that, and you only get the post state after execution. But with block level access list, you could have a function that looks like it takes the pre-state and the block level access list and outputs the post state. So you could do any checks that you would normally do post execution, you could do pre-execution. And this is kind of where it aligns delayed execution with fossil a little bit.
Thanks. Any questions, comments? Yeah, Lucas?
So one comment of mine about like scheduling, and so if we decide we want to do block access list, I'm a bit reluctant to include fossil before, because then with block access list we would have to rework fossil a lot. So maybe it would be better to include them both, or actually block access list going before fossil. just for redundancy of the work. It kind of seems, but it needs first decision if you want to include block access in the first place at all.
Thanks. Ansgar?
Yeah, more on the process side around block level access lists. Also discussed this a bunch with Tony. Basically, the way the structure of block level access list works is that it has two separate aspects to it. It's the read side and the write side. The current proposal, I think, for the reads basically only includes the location, and for the writes, the location and the values, each on a per transaction level. It makes a lot of sense if we want to ship both of these aspects of it to actually combine the implementation, because you can get a lot of synergies out of this. So you shouldn't have this completely separately specified. But in terms of governance, we should decide on both of these things independently. So I think we should really, maybe that means splitting the EIP. But either way, like, we should decide on, do we want the reads? Do we want the writes plus diffs? And then if we want both, we ship them in a unified way. But if we only want to ship one of the two, then we should basically explicitly talk about that. So just on the process side.
Thanks. Guillaume?
Yeah, I mean, that's kind of building on what Ansgar said. I am generally supportive of block access lists because I think it's a good first step to what I want to happen next. The biggest issue I have with scheduling this right now is that there's actually 5 flavors of it, and I think actually there's a lot more, and we need to really limit the amount of moving parts, so that we know what we ship. Because no, we're not gonna ship like we can't do it in 5 steps. Like it's completely useless if we just move this in like many steps, because some of it might not be shipped, some of it you might change your mind and realize you took a wrong turn. So you need to get the final design, and I would say this EIP is quote unquote small enough that we could reach a design. But I think before we even talk about scheduling it, and Tony knows my opinion, so it's not a surprise to him. I think before we talk about scheduling him, we should really get this this design and properly understood.
Thanks. Sam?
So on some level, one or more flavors are already there, and like historically enabling parallel execution and so on. We have had some EIPs in the past as well. Tony, do you know why we did not ship this or a variation of this in the past, and what changed now that we're in a position to do it?
Yeah, I think this is primarily because the community had some very clear stance on what we want to achieve in the next 1 or 2 years, and it feels like L1 scaling was definitely on that list, and I would even say on the top of that list. So I would say the focus shifted towards looking more into L1 scaling and block level access lists. So parallelization was always a thing, and it is a thing today, right? All clients, or almost all clients, have some prefetcher logic, some preloading logic that already achieves that and is very good for that in the average case. Block level access list would now go one step further by making sure that every block is parallelizable. There is this other EIP, I think it's 7825, with the capping the gas limit. It is also already a step into the right direction there to make sure that blocks are actually parallelizable, no matter if it's the worst case or the average case. And just one more comment, I totally agree with what Ansgar and Guillaume said. We have to kind of get to the final design as fast as possible. The 5 designs that were mentioned, this was just the first post I had on design space exploration. But in the meantime, I've been talking with some client teams. There was also a lot of great input in the Discord channel, so check that out. And essentially, it felt like what clients wanted was the post-transaction status, because this has many different advantages, not only for parallelization, but also parallel state root calculation or for execution-less state updates. So the post-transaction value seemed like something the clients really wanted. And the storage locations, this is then something where clients could replace prefetcher code with the storage locations, because this is just a deterministic list that is 100% correct, and it always gives you the right locations, and you're never in the position where you run your prefetcher and it's actually incorrect. I think that's kind of it.
I want to just add that I disagree that this wasn't the focus, because vertical trees and its witnesses carried a lot of these properties that we are now simplifying, let's say, with block access lists. So it was the focus of research for the last few years. It's just in a more complex form, and now it's being somewhat simplified with this proposal.
Oh yeah, totally agree. I was more thinking of focusing on kind of how to make it best for L1 scaling.
Are there going to be any, my apologies, changes in the block size because of this? Let's say you've managed to scale the block 10x of what it is, and then you have to ship a lot of extra data as well, because right now that is not being taking place, and like with higher block limits and more transactions, the bandwidth would be like a premium.
Yes, this is correct. So block level access list would add some additional size to the current block size. The worst case is not a problem here, because the worst case would be around 0.9 megabytes. So this is smaller than the worst case from call data, and the two are exclusive. So you cannot build a block that has a lot of call data and a big block level access list. But we should more focus on the average case here anyway. And on average, the block level access list design, as it is in the EIP right now, would add on average 40 kilobytes per block. And this is definitely a non-negligible increase, and we should carefully analyze that. I think when we look at the pros and cons, I think it's worth it. But this is definitely, I would say, one of the most important points to stress here, that the block level access lists are not like a super small object compared to anything that requires witnesses. It's very small, but yeah, definitely some block average block size increase.
Ansgar?
Yeah, on this point, I just wanted to briefly add a kind of caveat, just that indeed, as at current throughput levels, and especially at current pricing levels, even if we were to increase throughput, this kind of extra data consumption is indeed not a concern, because for the same gas that you otherwise would have spent on call data, you already like spend it on state reads or writes instead, and so you can't spend it on call data. So the worst case block size does not actually get worse. However, there's a big caveat there, because going forward, we have more headroom to scale state accesses, reads or writes, then we have to scale data. And so this could actually change in the future. So basically, we are locking us potentially in. And basically, as we would want to change that pricing, we would then hit that wall that now basically there's this limit. Same thing where we are looking into these like multi-dimensional pricing, again, a bit of a scary term, but like basically just like make it so that you can consume call data and execution at the same time. Now that would then also basically run into this bottleneck. None of this, again, this is just a qualitative argument, not a quantitative argument. So I think over the next few weeks, we will look into quantitatively what does it actually mean, at what kind of relative consumption levels, gas limit levels that would actually start to be constraining, start to become an issue. And then hopefully we have an empirical basis to actually make the decision. But I just wanted to flag that this argument that Tony just brought up holds at today's levels, but not necessarily in that future that we're aiming to enable here.
Thanks. Okay, anything else on block level access lists for now? Otherwise, I do want to come back to this pay opcode and DevNet inclusion. So previously we said we would remove pay from Fusaka. It seems like a bunch of people in the chat voiced that they would actually like to keep it, and some of the client teams said they already have implementations or the implementations are trivial. So there was a been asked, or should we consider this for DevNet 3 for Fusaka? So a few minutes ago, we said we wanted DevNet 2 to be the last DevNet in Fusaka where we add things. I think even if we want to add one more with DevNet 3, we should be clear that like we need to ship what's in DevNet 1 and then what's in DevNet 2. And then if that all goes well, we could potentially add pay to DevNet 3. But yeah, how do people feel about that? Do we want to keep pay CFI'd and then add it to DevNet 3 if everything goes wrong, everything goes correct, and we don't see major issues in DevNets 1 and 2? Yeah, Ben?
Yeah, it's a very simple opcode in terms of it's just full, but you delete 90% of the implementation. The main thing would be around testing it, I guess.
Okay. Since Besu also wanted in DevNet 3 at the latest 3. Yeah, Lewis?
Yeah, so this came about in EOF. Well, it was mandatory to because of to include it because of the not passing the gas to the call anymore. But it was still useful as a simplification for, and even security-wise for mitigating reentrancy in calls. So I haven't seen that much pushback on arguments against it. So yeah, would like if there's any arguments against it. But it's a really simple one, as Ben said, to add.
I mean, I feel like I gave arguments against it last all core devs, which is that it's a very simple thing to implement, but the implications of implementing it are not as simple. And I don't know if people have thought really deeply about is this how we want people to use the EVM going forward. It seems like something that people just want to do because it's easy and we can just do it. And it might make some people's lives easier, but have we thought about, is this really what we want the EVM to look like? Because we can't undo this.
Okay, so as I think the use case is already available through self-destruct, so it's not something new that we're gonna add. It's just making it explicit with the opcode.
Yeah, I'd like to add to like Line's point is that it changes the tracer, and if you want to trace historical balances, it just adds a new mechanism to transfer ETH, which is fine. My only worry is that it's maybe too late for Fusaka, and it's easy to implement in the EVM, but it has non-trivial consequences down the stack, and we are disregarding that. We're only thinking, oh, it's easy to implement. Let's implement it.
Okay, so I think I'm fine leaving it CFI'd if we want for the next 2 weeks, but I think we should definitely have a better grasp on the implication if we are to include it in DevNet 3. But I would not.
But we're not going to get that in the next 2 weeks.
So if we're not, then should we just remove it?
Is it possible to move it to CFI for Amsterdam or something?
I would not do that yet. When we do this, it's like we can propose it again for Amsterdam. We can have that conversation again in a few months, but I think it would be a mistake to decide today when we don't even know what the biggest feature for Amsterdam will be. Yeah. So like nothing against considering it for Amsterdam, but I think we should make those decisions independently. Yeah, Daniel.
Yeah, I just wanted to say we should be careful not to repeat a similar mistake as with EVF, and maybe ask smart contract developers why they want it, to get outside voices, because there are things maybe that we are missing.
Okay, so this makes me lean toward like, yeah, previous decisions, removing it from Fusaka and reconsidering for Amsterdam. And if it's mostly a question of like design implications and community support, then we have plenty of time to do that for Amsterdam. And if it's a trivial implementation, if it's a trivial implementation, then it shouldn't be too big to add to the fork, regardless of what goes in. But yeah, given we're already pretty full for Fusaka, it was already a stretch to include this in the third DevNet. I would lean towards removing it and just keeping your scope as is for basically what we had for DevNet 1, and then adding 7912, 7934, 7907 to DevNet 2. Okay. One more thing that I wanted to bring up on this call. So there was an EIP in the past about a versioning scheme for EIPs that the testing team had put together with Nethermind. They wanted to discuss it again on this call. Yeah. Yeah, Aman. Yeah.
Yeah. Hey, so I won't take much of everyone's time. I just wanted to go quickly and suggest that we do EIP versioning scheme for all the EIPs that we plan to include for Amsterdam, which means that any EIP that reaches the review state should have a version, and then any consequent changes should probably add an amendment at the end saying what was the change, if it was just a linguistic change or a deeper change, etc., based on the spec that is written in the EIP. There were concerns raised from Tim about the friction that this would add to the process, and I think that we, like all core devs, have had instances where tests and client implementations did not align just because we were not sure about the version of the EIP that these tests were testing, or the version of the implementation of the client that we are trying against these tests, or that even the version of the spec, like as in EELs, that we are using to generate these test what they're called? Yeah, to generate like the tests. So like a lot of things would benefit. A lot of things in the process of the development and implementation of these EIPs would benefit from this versioning scheme, and this little friction that this adds shouldn't account for. Should be like outweighed by the benefits that we get in testing, etc. And yeah, like I'd like to hear from everyone their opinions, and potentially if there is like if people haven't even haven't started looking at the EIP, please do, and like we can decide on it later, obviously.
Yeah, I've looked at it in the past, and I frequently wrestle with the EIP bot and harass people to go wrestle with the EIP bot. So I think anything that's blocked on the EIP bot, and like anything that's like a strict enforcement, is something I would have like pretty big concerns on. Like I would basically want us to come up with like a proposal for how do you actually automate this and not add more friction to the process if you ship it. My counter proposal was like, let's just use the hash because we get it for free every time we do a commit to the EIP. I think this gets you basically the value of clearly identifying the changes, which is like half the battle. It doesn't get you this idea of like, okay, the magnitude of the change, and it doesn't quite couple it to the process. But I think if that's kind of what we want, like, then we should probably just have a much deeper rethink of EIPs around, like, you know, what do we want statuses to mean? How do we want that to work with versions? How should that work with DevNets and whatnot? And to me, this feels like a much, much bigger can of worms that, like, we shouldn't just add a new versioning scheme about, like, the updates to the EIP without taking this into consideration. So I would say, like, if we want to say that, like, the hash is like the official version, have a way to automatically add that to the EIPs with a bot or something, strongly support it. But I think any sort of versioning scheme should be much more comprehensive and reflect, like, the EIP state, the hard fork state, and all of that. And we should make sure the automation is set up to support it. Yeah, Andrew.
Yeah, I agree with you, Tim. I think this is a bit unnecessary, this extra version, and it introduces more friction because we can always check the history in GitHub. But I think what would be helpful is to be stricter about freezing EIP commits on the DevNet spec, because sometimes we do it and sometimes we don't. And I think that this is really helpful because this gives us the level of that we should target. So we are targeting DevNet, say 5 versions. We are doing tests for DevNet 5 versions. We're doing implementations for DevNet 5 versions. Everything is frozen, and we should do it, like, reasonably well in advance. And like, new commits can be merged and so on. So, but we'll have an explicit, like, for DevNet 6, we can see the diffs between the commits and update everything to the DevNet 6 version.
Hi.
Yeah, hi Dan.
It's Dan here from the testing team from East. Thanks a lot, Tim, for the input about having a more sort of fully encompassed solution, and I completely agree. So I think my proposal would be, as the EIP 7577 stands now, it's a little bit out of date because that was written when we used the first available reference implementation from any client team in order to fill the test for an EIP. And now we've moved since Prague DevNet 5, I think, of September, like last year or October. We actually generally, and I think we've managed to always use EELs as the reference implementation, as it should be. And if EELs was more tightly coupled with the EIP process, that if you propose an EIP and you get, like, CFI'd, then you should propose an implementation in EELs. And the EIP document is tightly coupled to this EIP implementation, then it becomes a bit more reasonable to start adding a versioning on top of that. I don't want to take up much more time. It's just a thought that we've had in the meantime. Thanks.
Yeah, I think this is, like, an important discussion to have. But I do want to make sure that whatever process we have or whatever, like, scheme we use is both like, semantically useful, like we know what we're getting out of it, but also not completely independent from the other parts of the process. So my proposal, if we just want to track changes, then commits or commit hashes are kind of nice because you get them for free. And then if we want to have a much more comprehensive thing, I think it should encompass a bit more. But yeah, I think it's worth continuing this conversation, I think, and happy to trial something for Amsterdam as we work through the fork, which obviously we would then adjust. Yeah. We're already at time with this. Anything else people want to bring up quickly before we wrap up? Okay. Well, oh yeah, Ben.
Just the issue, the block count max per transaction that was just raised about sort of peer dash related, but it is where is it? re-forward this. Alexi raised.
Okay, we're already past time, so let's have people review this, I think.
All right. Thank you. See you. Bye.
Thanks, everyone.
Bye, Marius.
Thanks, Marius.
Thank you.
Bye.
Bye, everyone.
Bye.